Okay, so I'm going to try to record some video here to help you learn how to graph rational functions when they give us the equation. So one thing you want to pay attention to is in the purple notes is that summary sheet. Let's see, do I have that? Let me see here. Yeah, it's on the front, for the front page, this page here. So you want to read that, take a look at that, make sure you understand what bottom heavy, top heavy, and same power means, and how that relates to horizontal asymptotes. And then we're not going to worry too much about the interval work. This master math mentor likes to have you do that. We know about 1 over x squared, and we'll look at something like that. Sometimes you got to, sometimes you have to. But anyways, let's jump in and do some of these questions. So this first one in the examples, what do I see? Well, you've done, the work we've done already. Here, let me get a pen going here. When the denominator equals to 0, then we know there's a vertical asymptote. So I know there's a vertical asymptote when x equals -2. That means the domain, I mean, I could do this with interval notation, but for simplicity's sake, I'm just going to say it can't be equal to -2. So let's go ahead and graph that. X equals -2, there's a vertical asymptote. So here, I'm going to put a dotted line to represent that. Give me a visual. And then I notice that this is the same power. I see it's x to the first over x to the first. You look at that shortcut handout there. It says, well, when it's the same power function, it's the ratio of the coefficients. In this case, both the coefficients are 1. So we got a horizontal asymptote y equals 1. And then where is it 0? Well, we know it's 0 where the numerator equals 0. So that's when x equals 4. So they cross the x-axis at 4, 0. We'll put a point there. And we'll skip the interval work for a minute. Now, remember the y-intercept, and we've done this with polynomials before. If x equals 0, then we know that the y-intercept in this case is going to be -2, because -4 over +2 is -2. So it's going to cross the y-axis at the point 0, -2. So what is that? How does that help us now? I think we've got everything we need. Remember, this is just a transformed reciprocal function, 1 over x. And we know the typical everyday untransformed 1 over x function looks like this. And sometimes, if it's been reflected around the x-axis, it flips, and we can pay attention to this without worrying too much about what it looks like. I see a graph. I know this is a horizontal here. Let me get fancy and go with a different color ink. I know this graph has to cross the x-axis here. It has to cross the y-axis there, and that's a vertical asymptote we can't cross. So it looks something like this. Yeah, we'll graph it a little bit. And there's the horizontal asymptote. And so since this graph is here, and I know it isn't going to cross the x-axis at any other point, I know it's not going to cross the y-axis at any other point, it kind of is locked in to this corner right here. And that's exactly what it kind of looks like. And we didn't have to do any kind of interval work. I didn't think about that. And it's that easy. Find your vertical asymptotes, find your horizontal asymptotes, find any zeros, the y-intercept if you can, and then think about 1 over x and 1 over x squared. Okay, so there's that one. Now let's see, let's clear all drawings. Let's come down and do example number 2. Okay, this is a little different looking. Let's see, so the domain, the vertical asymptotes, I know the denominator can't be equal to 0. So that tells me the vertical asymptote happens at x equals 3, which tells me the domain excludes 3, and I started writing -3. I see a bottom heavy function because there's no x value on top, so that means it's x to the 0. And that means x to the first and bottom, and the denominator is the bottom heavy function. That tells me the bottom is growing faster than the numerator. That means it goes to 0. So when I have some number divided by a big number, doesn't that go to 0? So that's what's happening here. So let's see, let's do a little bit of graphing here. Let's see, x equals +3 is the vertical asymptote. Nice vertical line. And then I know there's a horizontal line or asymptote right here on the x-axis. How about zeros? Well, -4 will never be equal to 0, so that tells me there's no zeros. It'll never cross the x-axis. And then how about the y-intercept? Well, if f of 0 equals -4 over -3, because 0 minus 3, right? So that's going to be positive 1 1/3. So it crosses the y-axis at 1 1/3. So we'll eyeball that. Okay, so because that's locked in, and we know there's no zeros, this tells me this graph has to look like this. It's going to come down, cross the y-axis there, then head out, approaching 0 there. And that means because it doesn't cross the x-axis or the y-axis in any other place, it's going to look like this over here. Okay, notice it acts like 1 over x. It's been transformed. I mean, we could think about it that way. Can't we think about this as -4 times 1 over x minus 3? And that's, I see a reflection around the x-axis. I see a vertical stretch by a factor of 4. I see it's been shifted right 3, and that's really what we're seeing. Because remember, normally 1 over x looks like this, right? So it's been reflected around the x-axis. So you don't have to worry about all that, but it all works, it all holds. Okay, hopefully that helps. Let's go do another one. If you want, you can stop the video and try it yourself. So I see a bunch of stuff that's I need to do some factoring here before I do anything else. I see a greatest common factor of x in the numerator. So I'm going to factor out an x. Whoops. X plus 3. And then the denominator, I see a quadratic that factors to x and x. And what multiplies to give me positive 6 that adds to give me positive 5. Well, I think it's plus 2 and plus 3. So what's kind of cool about this is, you remember from our work earlier where we had a hole in the graph? I see there's a common factor top in the numerator and the denominator of x equals 3. So that tells me there's a hole in the graph at x equals -3. So that means there's only going to be one vertical asymptote, and that happens at x equals -2, right, from this factor, right? And that tells me now, just because there's a hole at -3 and not a vertical asymptote, the domain still doesn't include it. So x doesn't equal -3, and x doesn't equal -2. What about zeros? So actually, HA, let's talk about that. I see x squared over x squared. That means the horizontal asymptote is going to be the ratio of the two coefficients of x squared. So that's just y equals 1. Let's get a little bit of this graph and done before we get too far here. See a vertical asymptote at -2 and a horizontal asymptote of y equals 1. Let's think about zeros now. Well, I know normally if it didn't have the x plus 3 in the denominator, there'd be a 0 at -3. But since that's a hole, I'm going to say x equals 0 is the only 0. So let's graph that. Let's see, what else? Oh, the y-intercept. Well, the y-intercept is going to be 0, 0 also, right? Because if you drop 0 into the numerator, it'll be 0 divided by 6, which is 0. Okay, so I'm seeing this. I know this graph has to look like this. Has to cross the x-axis at 0 and then head down. And that means it has to come like this, something like this, except I know when x equals -3, there's a hole. So right there, I'm going to put a hole. And it looks something like this. Yeah, there's other analytic ways we can find out exactly what that value is. That's really more of a calculus idea. Right now, we won't worry about it. We know we're pretty close. So check it with a graph and calculator or Desmos. Make sure I'm not lying to you. I think I'm right though. Okay, let's come back and do example number 4. So here, let's see, let's do some factoring again. So x plus 4 times x minus 4, because the difference 2 squares. And in the denominator, I'm going to get x plus 2 times x minus 2, another difference of 2 squares. I don't see any common factors, so the domain doesn't include -2, and the domain doesn't include +2. Doesn't include. So that tells me there's a vertical asymptote at -2 and a vertical asymptote at 2. Let's take care of those. Get those vertical lines in. I see the same power function, so it would just be the ratio of the coefficients. So y equals 1 is, again, the horizontal asymptote. How about zeros? I know it's wherever the numerator equals 0, so that tells me at -4 there's a 0, and at +4 there's a 0. So let's graph those. Okay. Y-intercept. Well, if we drop in 0, isn't that 0 minus 16 over 0 minus 4, which is going to be +4. So it crosses here. So now here's where this is kind of cool. I know that both of these at the vertical asymptotes are going to act like 1 over x squared. I know that this graph has to cross the x-axis here at 4. So that means that's that piece, and this will be this piece. Then we got to ask ourselves, what happens in the middle? Well, I know it crosses the y-axis at 4, but it doesn't cross the x-axis, and I know it acts like 1 over x here on the right-hand side, and that must mean it turns around right there and heads back up. So do you see how that made pretty short work of everything here? We knew we couldn't cross the x-axis again. So that's how that graphs. All righty, let's come down to number 6. Boy, there's a lot of exercises here, but it's good to see a lot of them, and it's good. I think it's good to have me work through a bunch of them for you. And you can certainly jump around and not watch all this video. Numerator factors to x plus 3, x minus 3, difference of 2 squares. The denominator is interesting because that's the sum of 2 squares, and some of you are going to fall for that. Well, that just doesn't factor. So how about the domain? Where does that denominator equal 0? Well, isn't that x squared equals -4? And I can't take the square root of -4. So that means that denominator will never be equal to 0. So the domain is all reals. That means there's no vertical asymptotes. I see the same power function, and the ratio of the 1, so y equals 1. So let's take care of that horizontal asymptote. And I know it's equal to 0 when x equals -3. And when x equals +3, here, I'll write that here. So -3, 0, and 3, 0. You do see that I got those out of the numerator, right? Okay, what's the y-intercept? I see if x equals 0, that's going to be -9 over 4, which is -2 1/4, right? So it's going to cross about here. And I know there's no vertical asymptote, so this graph has to look like this. Approaching that horizontal asymptote, we're going to drop down past the 3, then it's going to hit the y-intercept. It's got to turn around, head back up, and then head out towards that horizontal asymptote. And that's what that looks like. Okay. Well, give it a whirl, folks, and come back and watch. Okay. Numerator doesn't factor, so that'll never be equal to 0. It's not going to factor because it's the sum of 2 squares, right? So there's no zeros. That means it'll never cross the x-axis. In the denominator, I'm going to treat it this way. I'm going to factor out a negative. That means that factors to x plus 1, x minus 1. So that means the domain, so there's a vertical asymptote at -1, and 1 at positive 1. That means the domain doesn't include negative 1, and it doesn't include positive 1. So let's put some vertical asymptotes in there. Alrighty. I hope I'm not making this look too easy, because what happens, I went through and did these. And yeah, I made some mistakes. So that's why I'm able to do this fairly quickly. Now, how about the horizontal asymptotes? Well, I know if it's the same power, it's going to be just a ratio of the coefficients of the biggest degree of the leading term. And I'm just going to rewrite that denominator so it's negative x squared plus 1. I see the x squared over x squared, and I see a 1 over negative 1. So that tells me the horizontal asymptote is negative 1 this time. And how about a y-intercept? Well, if we substitute in 0, don't I get 4 over 1? So 0, 4. All right. And there's no zeros, so it'll never cross the x-axis. So I'm guessing since it never crossed the x-axis, this is going to be kind of like the last one, right? That's got to come around and turn around. And since it can't cross the x-axis, it's going to look something like that. Yeah, I think that's about what it looks like. I mean, yeah, I probably don't have the curves quite right, but we get the general idea. Okay. All right, what's happening here? I see, I spy with my little eye. Let's do some factoring. I'm going to factor out a 2. Then that factor is difference 2 squares. And the denominator, I see a greatest common factor of x. So I'm going to factor out an x. So domain, well, I know the domain doesn't include 0, because when x equals 0, I get something over 0. And I know that can't equal positive 3. So, and I don't have any common factors, so that tells me there's a VA at x equals 0 and x equals 3. So I'll try to fit in that x equals 0 and x equals 3. Zeros. I'm sorry. Same power function. So that means y equals 2 over 1, right, is the horizontal asymptote. So there's horizontal asymptote right here. The zeros, where does the numerator equal 0? I see it's, if I divide both sides by 2, that doesn't come into the mix. So negative 1 and positive 1. So negative 1, 0, positive 1, 0. So crosses here and here. Remember, there's a vertical asymptote here at x equals 0. Y-intercept, if I drop in 0, doesn't that give me negative 2 over 0? So there's none. There's no horizontal, no vertical asymptote. There's no y-intercept. So how do I fit all this in? Well, let's see. I know it's got to approach there. I approach the horizontal asymptote. It's going to come down through the x-axis, and then it's going to approach that vertical asymptote at x equals 0. And there is a vertical asymptote at x equals 3, right? And I know it's not squared, so it's got to act like 1 over x. So I'm going to have this graph come up like this. Ooh, you know what? I just did this wrong. Why did I do this wrong? Because I treated this x like it was the vertical asymptote, but x like it was 1 over x squared. They're both headed into the same direction. So let's see if I can't erase some of this here. So that means this graph has to come down like this. Cross through x equals 1, and then head down towards there, which means this has to act like this, because it has to act like 1 over x. We also know it can't cross the x-axis at any other place between negative 1 and 1. Okay, so that's what it looks like more or less. So now what I'm seeing is a top-heavy function. And since it's top-heavy, there's going to be no horizontal asymptote. There's probably going to be a slant asymptote. There will be a slant asymptote. Oblique asymptote is what this guy calls it. So we're going to do with this question, since I'm dividing by a linear term, I'm just going to do synthetic division here. Since I got plenty of room, why don't I move this down a little bit? So let's do that synthetic division with this. So remember, x minus 1 is the factor, so we're going to divide by x becomes positive 1. So 1, and I'm not missing any powers of x, so 1x squared minus x minus 6. Bring down the 1, so 1 times 1 is 1. Add those, you get 0. 0 times 1 is 0, gives me negative 6. I started with an x squared, I divided by an x. That's telling me that's x plus a negative 6 over x minus 1. So what I'm seeing is this is the slant asymptote. The quotient will be the slant asymptote. So it'll be the y equals x. I see, if I go back to the original, I know x can't be equal to 1, which means there's a vertical asymptote. Well, maybe we should make sure, and before I say this, let's factor that numerator. Doesn't that factor to x minus 3 times x plus 2? That way I'm going to get negative 6. So yeah, there's no common factor. So there is definitely a vertical asymptote at x equals 1. There's no hole. So the zeros, where does the numerator equal to 0? Well, at positive 3 and at negative 2. And if I drop in 0 for the y-intercept, or 0 for x, doesn't that give me positive 6? Because that's 0, that's 0, that's 0. Negative 1 over negative 6 over negative 1 is 1, 6. So let's do some graphing here. Let's see, a VA at x equals 1. I know there's a slant asymptote of y equals x. Well, that is a graph. That's a line that goes to the origin and has a slope of 1. So I know it looks something like this. I know there's a 0 at 3. I know there's a 0 at negative 2. And so here's what I want you to think about. If it's just 1 over x, doesn't the graph look like that? Well, what happens if I tilt this up? Doesn't that just crunch those lines like this? So that's what we're going to look like. Except in this case, because I've got these zeros, I got to make sure it crosses those zeros. Did I do the y-intercept at 6? Here we go. So I know this graph looks something like this. And I know it crosses that x-axis, x-intercept. It doesn't cross that x vertical asymptote. Crosses the x-axis there and heads like that. So it looks something like that. Just see how it follows the slant asymptote, that horizontal, that oblique asymptote. Not much different. Just it's actually very similar. Just going to do that synthetic division or long division, you'll see in some cases to find out where to graph that oblique asymptote. I had a couple more of these to do. Okay. Well, let's see. Let's do a little work here since we can. I see it factors to x plus 3 over x plus 2. So I don't see any vertical. I don't see any holes. So the domain doesn't include negative 2, and there's a vertical asymptote at negative 2. Now we're going to do some division. Well, since we're looking for where does x plus 2 equal 0, that's at negative 2. And then so 1 and 3, and then I need to include a 0 because I'm missing the constant term, right? So bring down 1. 1 times negative 2 is negative 2. That's 1. 1 times negative 2 is negative 2, which is negative 2. So I started with an x squared. That means this is 1x plus 1 plus a remainder of negative 2 divided by x plus 2. So here's my oblique asymptote, my slant asymptote. Y equals x plus 1. So where does this graph equal 0? Well, I know it equals 0. The numerator equals 0, so it equals 0 at 0, 0, and at negative 3, 0. since if we dropped in 0 into this, the y-intercept is also 0, 0. So let's do some sketching here. Let's see, -2 is the vertical asymptote. I've got a slant asymptote of x plus 1. Remember, this is 1x plus 1. So I'm going to start at 1. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. I'm going to draw this as a dotted line because it is an asymptote. Let's see, 0, 0 it crosses. At -3, 0 it crosses. So this graph has to look like this. Follow that vertical asymptote. Cross the x-axis there. Follow that asymptote. Maybe I should change ink. Yeah, so there's that graph. Crosses the x-axis. Heads down here. This one follows that. Crosses the x-axis there. And follows that. Go ahead and graph these with Desmos. Make sure I'm doing them right. Okay, what's happening here? So I got to do some synthetic division at 1. I see it's a top-heavy function. And that gives me a 1x cubed, but then I get a 0x squared, 0x, 0 constant term. 1 times 1 is 1. Atom 1 times 1 is 1. Atom 1 times 1 is 1. So that leaves me x squared plus x plus 1 plus 1 over x minus 1. Now, I don't know if you remember, but this has this quadratic, this parabola has no real zeros. That's the one you can, if you want to test to see if there's complex roots, do 1x squared plus x plus 1. So that tells me, how do I know where to graph this? Well, I mean, yes, there's a graphing calculator you could use. However, if you think about x equals -b over 2a, we'll find the vertex of this. So -1 over 2 times 1, that tells me the x coordinate of the vertex is -1/2. Now let's drop that in to find y. We're going to find f of -1/2. So that's going to be 1/2, -1/2 squared is 1/4, minus 1/2 plus 1. Well, isn't this going to be 5/4? 1 is 4/4 plus another quarter is 5/4 minus 2/4. Well, that is 3/4. So that means the vertex is at -1/2, positive 3/4. So right about there. I know this graph has a y-intercept at 0. Because, well, let's see. I'm getting ahead of myself. Here's not really a slant asymptote. It's actually a parabola. I know there's a vertical asymptote at x equals 1. The domain doesn't include -1. That's because of the denominator. So let's see, +1. Let's see. I know this is a parabola that opens up. So this asymptote will look something like this. I mean, normally that would cross the x-axis at 1. And then somewhere over here it looks something like that, okay? Now remember, these are asymptotes. These aren't the graph. I already know that this has a 0 at 0, 0, right? Because if I drop 0 in for x, it's going to be 0 over -1. So this graph has to cross the origin. I also know there's a vertical asymptote here at +1. So this graph must, the other thing to keep in mind, doesn't this x equal 0, it doesn't have multiplicity 3 because of the exponent. So that tells me this graph has to, here, let me go to red ink. This has to follow that asymptote, wiggle through that 0. Actually, I don't know why I'm making them I'm making it dotted because this is the actual graph. It's going to wiggle through that, and then it's going to follow this parabola. Now, how closely does it follow? You could plot some points, but aren't we really just trying to find the general shape of this? There, wiggle through that 0, and then because it needs to pass the vertical line test, the only other place we can graph that parabola or graph that line is here. This isn't actually a parabola. This is part of the rational function, okay? Now, if you go graph this in Desmos, make sure you zoom out, and you'll see that I'm right. I've done this, so I know. 0, 0 is the y-intercept, along with that. Okay, a little tricky question, because you got that parabola to follow. I won't lie to you, it's not fun. All right. So now, what do we got going on here? Let's see. Well, I know the domain doesn't include -1. So there's vertical asymptote at -1. I think so. I mean, maybe -1 is a factor and it'll be the 0. But so let's check that out. And what is a top-heavy function? So I've got the 1x cubed. I've got the 1x squared. I have a 0x minus 2. So there's a 1. That's -1. That's 0. That's 0. That's 0. That's 0. That's -2. So what do I see? I divided an x cubed by an x. So that leaves me x squared. So y equals x squared. I see, what do I see? I guess I got to figure out the 0. So that means I need to figure out where does that equal 0. Well, I could. I mean, the way I had you do this with polynomials is I had you graph this part on Desmos and look for the zeros. And I won't bother you doing that because I have done this. Let's see. Is this it? Yeah. So that has a 0 at here we go. This had a 0 when I graphed it at x equals 1. I'm just talking about the numerator. Okay. So x equals 1 was the 0. Let's get some graphing going here. Let's see. Vertical asymptote at -1. A slant asymptote of y equals x squared. Something like this. I know it crosses the x-axis at 1. It also crosses the y-axis at -2, right? When x equals 0, I get -2 over 1. Okay. So here's what I think this graph looks like. It's going to follow that parabola, hit that 0, cross the y-axis, and it can't cross that vertical asymptote. So it's going to come down like this. And then since I can't repeat it, I don't want it to not be a function. I think here's the other part. Go graph it and check it out. Make sure I'm not lying there. And is there one more of these? Oh, good, good, good. One more. You'll be glad this video is almost over. I'll be glad that I'll be done making it. Let's see, where's my pen? All righty. So I see a quadratic in the denominator. I can't do synthetic division with this. I got to do long division. So x squared minus 16 into x cubed minus 4x squared minus 11x plus 30. At least I'm not missing any powers of x. So what times x squared is x cubed? Just x. X times x squared is x cubed. X times negative 16 is negative 16x. Change the signs. That leaves me negative 4x squared. Let's see, plus 5x plus 30. What times x squared is negative 4x squared? Negative 4, so that's negative 4x squared plus 64. Then we got to remember we're subtracting, so we're going to change our signs. That becomes positive. That becomes negative. That leaves me with, I'm running out of room on my screen, positive 5x minus 34. And that's going to be over the x squared minus 16. And my slant asymptote is this, y equals x minus 4. So let's see, y equals x minus 4. The vertical asymptotes happen when that equals 0. Well, x plus 4 times x minus 4 equals 0 at negative 4 and at positive 4. Can't equal. So x equals negative 4 is a VA. X equals positive 4 is a VA. So there's a vertical asymptote. Here's a vertical asymptote. Now I'm assuming there's no holes here. I don't really remember, to be honest with you. Zeros. So we're looking for where there's a numerator equal to 0. Well, if we graph just that polynomial part, let's see. I'm trying to find my pages here. It took a lot of work. Here we go. I believe that polynomial had zeros at negative 3, at 2, and at 5. So I'm going to graph those points at negative 3, at 2, and at 5. Let's see, the horizontal asymptote is x minus 4. So minus 4, is that right? Yeah, is that what I did earlier? Yeah. So this is a line of 3, so it's something like this. And so it's going up 4 over 4. So something like this. Okay. It has a y-intercept of, let's see, if numerator just becomes 30, the denominator becomes negative 16. Well, that's about, not quite negative 2, right? Not quite, so about negative 1.216. So just better than negative 1. Negative 1 in a little bit. So that's right about there. So I think this graph looks like something like this. Put this all together now. Well, I know it's got to follow that asymptote. It's got to cross that x-axis right there. It's got to follow that vertical asymptote. We know it acts like 1 over x, so this graph has to come down like this. It's going to cross the x-axis there, cross the y-axis there, cross the x-axis there, and it's going to head back up. And then we know it can't cross the x-axis anyplace else, so this graph has to be down, this part has to be down here. This looks very flat here, could be the scale. Go check it out, make sure I'm right. So that's all these examples. I'll put my answers to the exercises online for you, and hopefully this helps.